Hello, guys. Good morning, good afternoon, good evening, as per your time zone, and welcome to this class of shell scripting. So, first of all, I hope you remember me. My name is Musab Sayed. I'm a Red Hat certified, and I have somewhere around 10 years of experience in which I have dealt with different technologies, starting my career as a Linux admin and then moved into AIX, virtualization, and a little bit of cloud as well. So let's talk about the shell scripting concept, what we are here for. Because basically, before we can learn about shell scripting, let's talk about few of the basics of Unix or Linux, and basing on that, we will try to understood the concept of shell scripting and we'll see what we are going to cover inside it. Guys, this is one of the book which I have written apart from Linux administration, and this is something what we are going to follow, which contains lots of examples and the whole thing what we are going to cover up in your shell scripting. So, first of all, let's try to talk about the introduction part. See, before we talk about shell scripting, let's understand what is that shell and how this architecture works and how the whole concept works around. So let me take you to MS Paint. Guys, the architecture of Unix works in this fashion. The topmost layer we have inside this particular Unix is called as user layer, and inside that user layer you will have the second layer, which is called as shell layer, and inside that shell layer we would be having kernel layer, and inside that kernel layer we would be having our final layer, which is called as hardware. So let me write it down for you. The innermost layer is your hardware, where all the commands are going to get executed. Then the next layer to it would be kernel layer. So this kernel is a very important component that is the heart of the operating system. Then on the top of kernel, we will have our layer on which we will be working always, which is called as shell layer. And the outermost, where we would be sitting as a end user. So that thing is called as utility or user layer. So these are the architecture of your Unix in which we will be working. To the end of this layer, we would be sitting as a user, and as a user, we wanted to do certain tasks. For example, I wanted to check what is date and time, or maybe I want to check how many partitions are there in the system. So probably what I'll do, I'll run a command. Where I would be running that command? So a user will be running a command on a shell. See, shell is an interpreter, the most important component via which a user can interact with the kernel. If shell is not there, then we cannot even talk to kernel and we cannot even ask our task to be completed. What happens, guys? Kernel is a component that works on binary language. So anything we want to input to kernel, we need to tell it in binary. It cannot understand human readable language. Then how can I talk to kernel and how can I give instructions in binaries? I don't know how to deal with binary. So here comes the role of shell, the interpreter. So we will use a shell and we will type a command in our human readable language. Now from there, what shell does, it converts the human readable language into binary and it will forward that instructions to kernel. Like I want to see date and time. What kernel does, it follows that instructions and it will go to a particular hardware and check that detail. For instance, to see date and time, it will go to CMOS battery and it will ask what is the date and time. Then CMOS battery will reply the time that this is so and so date and this is so and so time as per your system. Now that instruction would be given again to kernel in binary and the same kernel will forward to shell. Now again shell converts that binary input into human readable and then it will present it to the user. So this is how, guys, we would be working out with our Unix architecture. And you see over here how important role we have related to shell. So shell is an interpreter via which I am passing my commands to kernel and further it is going to take and execute the task for me. So if shell is not there, a human cannot even talk to your computer and he cannot able to work with that. So shell is a vital interpreter that help us to communicate with the kernel and to perform all the tasks in the system. Now when it comes to shells, we have different shells available. Like let me write it down over here. So when it comes to shell, we are having different types of shells available. Like the topmost, earliermost shell, what we used to have is SH or standard shell, which is also called as Bourne shell. Then we've got the next version of Bourne, which was called as Bash. Bash stands for Born Again shell, one of the most advanced shell in all operating system and widely used shell in every operating system. Very user friendly, very advanced and very easy to work with. Also we have some other shells like KSH, which stands for Corn shell, one of the toughest shell. See, by default in AIX operating system, you'll see it uses Corn shell. The problem with Corn shell is repeating the command or re-editing the last command is very complex and number of history what it stores is also less. Also related to C programming you have C shell or turbo C shell, right? Now this is not a C programming kind of thing. See, you cannot do C programming on C shell or TCSH. It is only to test and run your C programs over here. There are many shells are available. Also, you have one more shell over here, very special shell, which is called as no login shell. Now, what is that no login shell? I'll show you in a short while. So basically, this is the layer in which we are working, and out of that, the important layer is shell, and different interpreters and shells are used in order to work with your operating system. So as we understood that the most important part of the operating system is kernel that manages all the activities of your system: IO management, process management, device management, file management, memory management. And to pass instructions to that kernel, you need that shell. So how does it work in this fashion, guys? You have taken a shell, you are running a command. Now that command will be run on a shell, and shell will convert that into binaries and present to kernel, and kernel will understand your request and it will perform the activity. So maybe you are running ls command, date command on a shell, bash shell, then it will pass the instructions into binary 0110, something like that. Kernel will understood what you are asking and it will perform the activity. The same thing what I've explained here. Now, how many types of shells are there? Guys, as I've told you, there are various shells available. More than 13 types shells are available. Now, the leading topmost shells, what we have in all of them is BSH or standard shell, which is also called as Bourne shell. This was developed by Stephen Bourne for AT&T Bell Labs. Then the next version of Bourne came with the name Bash, which is leading the market in terms of shell. By default, Linux will have Bash shell, and it is used for all major operating system. Even now Windows is opening the doors for Bash. They have announced that Windows will now have Bash shell. So Bash stands for Born Again Shell, the newer version of Bourne shell. This was developed by Brian Fox and Chet Ramey for Free Software Foundation as an open source thing. Then we've got C Shell for testing C programs, was developed by Bill Joy for University of California. Then Corn Shell developed by David Corn for AT&T Bell Lab, which is used as the default shell in IBM. See, comparing to all shells, Bash shell is one of the easiest to work with, as the repeating of the last commands are very simple. It is very user friendly and very advanced also. See, in Bourne shell, what happens is, Bash shell, you can use tabs keys to complete your work. And next thing is, it can store up to 10,000 history commands, like whatever commands you have run in the previous time. So that is the real advancement of Bash, and that's the reason it is widely used on all major operating systems, all Linuxes, all major Unixes, and as I've told you, now Windows is also welcoming Bash. So we understood that what are these shell. Now how to access a shell in Linux environment. See, as soon as you log in into the system, you are starting to access the shell. For example, I'll go for a machine in my environment 10.40. This is Red Hat 7 machine. So when I try to log in into it, let me give my credentials, username and password. As soon as I log in, I will be accessing my shell. That's how the default behavior of shell will be working. Now how to know which shell I am using over here? See, you can use a command echo and you can say $0. This will tell you that which shell you are using. Maybe currently I am using a different shell, but my default shell is something else. So if you want to see which is your default shell, then you can use again echo dollar shell. This will tell you your default shell. So echo dollar shell will show you default shell, whereas echo $0 will tell you current shell. Also guys, I would like to see that how many shells are currently installed in my machine so that I can change my shells if I need it. So you can read one file etc shells. So when you read this file, it tells you that these many shells are available in your system which you can use it. So I've got bash, I've got Bourne shell, which is my standard shell. We've got no login, and we've got turbo C shell and normal C shell. Now maybe I'd like to change my shell to uh, C shell. Just you need to run CSH and you run echo $0. See, your shell is changed to C shell. But if you say echo $shell, it still says your default shell is bash. You changed your shell temporarily, but still your default shell is bash, that whenever you log in into the system, it is going to give you bash shell. To come out of the shell, you can simply say exit and you'll be back to your original shell with which you have logged in. So like that, you can access this shell and you can perform any activities, whatever you want to perform. Also guys, to check the default shells of all users, you can read etc password file that tells you all the details about users. So if you go to etc password, you see for root, it is telling that the default shell is bash. Similarly, if you go to etc password, you see it says there is a user, my user, whose default shell is also bash. So if you have knowledge of user admin class in Linux, there is a command called user mod. So using that user mod command, you can actually change this shell. And this is how you can change a default shell. For instance, I want to make C shell as the default shell for my user. Then you have to say user mod. See, with user mod, there is an option called -s to change the default login shell. So I'll say user mod -s, and just now we saw the path of the shell. For C shell, the path is bin csh. So I'll say use this shell as a default shell. For which user? For my user. Now if you go back and check it out etc password, now my user will have C shell as the default shell. Let us try login. Let me give my user and its password. You see echo $0. I'm on C shell by default, and echo $shell will tell you that that is your default shell. So this is how you can access the shell and you can change anybody's default shell. Now again, if I want to change my shell, I can simply use the shell name, and you see your shell will get changed to that. Say exit, you'll be back to your original shell. See, as a root, you have a power to change anybody's shell using usermod command. I'll say usermod -s and I'll change my shell. But can this command be run by an ordinary user? Usermod -s, I want to change my shell to bash as my user. It says permission denied. You are not allowed to run as a normal user. Then how can I change my shell, default shell, as a normal user? I don't have access to user mod. So there is a command called chsh, change shell. So when we run this command, it says tell me which shell would you like to make as your default. So I'll keep the path bin bash. It is asking your password and it is changed. Now if I say tail etc password, you see as a normal user I changed my default shell. So this is how guys you can access the shell and you can change your default shell as per your requirement. So every time root does not require to change your shell, you yourself can also change it by using that chsh command, change shell option. Also, in the list of shells, I talked about one more shell here, which is no login. Now what's that no login shell and when it is used? No login is a very special purpose thing which is used to restrict the users not to log in into the system. Whenever you want any user not to log in into the system, in that scenario, we will be applying it no login shell, sbin no login. Let's give my user no login shell and let's see what happens. So I'll say user mod hyphen sbin no login for my user. Now if you go and check etc password, you see that this user is having no login shell. Let me try to access this user by giving the username and correct password. See, it did not allow me to log in even though the password was accepted. You can try switching yourself su-my user. It says this account is currently not available. So this is the purpose of no login. No login is not a general purpose shell so that anybody can use it. It is for restricting a user not to access the system even though the password is active and valid. Let me again change it back to normal. User mod hyphen s to bash shell for a user, my user. Now if I go back and now if I try to log in, it won't be giving me any issues. Let me log in as my user and my password. You see I have successfully logged in. So this is how we have to deal with these shells. So as we were talking that as soon as you logged in into the system, you are accessing to your shell. You will be landing into the home directory and we would be accessing the shell, which will always be running in the background and which will be taking instructions from you and passing it to kernel for certain activities. Now the question here is, what is a shell script? See, script is something according to which you want to work. For example, you have a big environment and at a time you want to check 10 or 20 machines performance. So there are certain commands that you have to go to every machine and run that. So if you do it manually, it is going to take a lot of time. So I want to put it into a script, into a file, and I want it to go to automatically all machines and perform that task for me. So such kind of files that contain series of commands to be executed are called as shell script. So converting lengthy multiple commands, keeping it into one file, execute that file and all that commands will get executed sequentially. So that saves a lot of time for me and that reduce the efforts what I'm trying to apply. For instance, you wanted to create multiple users. Let's say I want to add four users, U1, U2, U3, U4. So I'll go for user add U1, then user add U2, then user add U3, then user add U4. So four times I've got to repeat that command. But if I know scripting, then I can use a small concept of loop called for loop. See, I don't want to go into the detail. I just want to show you that how the scripting can change the scenario. So there is a concept in scripting called for loop. What I'll do, I'll take this for loop. I'll say I want to create four users, U1, U2, U3, U4. So I'm telling that in this I value, I am using it as a variable. What is that variable? We will explain you in the coming times. As of now, just experience the magic of this loop. So in this value I am storing in that variable I'm storing four values u1, u2, u3, u4, and I'll ask it to do something for me. What? Run user add command for me. How many times? Dollar $I times. See, whenever you declare a variable, to call the variable, you have to use the dollar symbol. Again, we will see in more details in the coming time. So just I'm telling that repeat user add commands for I times. So in I, you are having four value. So it says user add U1, user add U2, user add U3, user add U4. Let me say done. Now if I say tail etc password, you see in single shot I'm able to create four users. So this is very small thing what I tried to show you. There are many major tasks what you can do like that in a very simple format. So this I have put as a direct command, but such things we will put it in a file and we will execute that file. So such files will be called as shell scripts. So that would be helping us to do tedious, boring, lengthy jobs into very simple and enjoyable manner. So you can convert or you can put lot of commands into one file and execute it to do any complex task in a very simple way. And also it will help you to automate your work. Instead of you doing everything on your own, you can let the script to do the thing for you. So that thing is your shell script. Now, why to use shell script? Just now we understood that it can take user requirement and perform the activities as per the user. And it is also useful to create our own customized commands. Save lots of time to automate day-to-day tasks, whatever you might be using. So to make our life simple, easy for day-to-day tasks, we require shell scripting. But shell scripting also have little bit of limitations. See, everything has two sides, advantages and sometimes disadvantages. Or in fact, I should not call it disadvantage. I could say limitation, something where it becomes little bit, you know, something heavy kind of thing or something not suitable. See, the thing is, compatibility problem between different platforms. Sometimes what happens, you might have created the script on Linux platform and same script if you use on Unix platform, maybe IBM AIX or Solaris. So they may have a different set of commands, and we on Linux have a different set of commands. So compatibility issues may come. Similarly, between different flavors of Linux also, we may have few differences. So that comes into the picture that it may not get compatible with different versions. Secondly, the execution of speed is little bit slow. Compared to other scripting languages, shell scripts are little bit slower when compared to them. And a new process launches for almost every shell command execute. See, let me explain you this in little bit detail. Like, assume I'm trying to create one script here, vim script 1, let's say, .sh. Now, probably in this script, let's say I want to keep multiple commands. Like I want to keep ls, I wanted to say tail etc password, I want to say password minus capital S username, or I want to say fdisk minus L, or I want to say uh, ps hyphen ef, something like that. So overall, 5 commands I have kept inside it. Every command will start a new process. ls will start a new process. Tail will start a new process. Password will start a new process. Fdisk and ps also start a new process. So every command you are running inside it will give rise to a new process. See, whenever a new process is started, it consumes resources of the system. So some amount of CPU and some amount of memory is reserved for every process. So like that, a new process starts, and amount of memory CPU will get reserved. Like that, there is a chance that your total resources may get exhausted easily. There is a solution what we can use not to have such activity in shell scripting, but by default this is the problem that every command in your script will get one process, and that is going to consume some resources. Now how can I create a shell script, and how can I write a shell script? See, to write a shell script, to create a shell script, basically you can take any editor you like. You can go with VI, you can go with VIM, Nano Editor, Emacs, whichever Linux supported editor you want, you can take and you can create your scripts. But as far as I'm concerned, I prefer VIM editor because of the color coding part that is available inside it. That's really beautiful. See what happens when you go with VIM, it prints the output in colors. So, for example, if I type something like that, or if I do something in the other one, if it is a command, different code. So, this coding of colors are really helpful for me whenever I am creating a lengthier script. If I make any mistake in the line, automatically it will turn into red color. So that makes me realize that something I have not done correct over here. For example, I'll do over there. You see, the bottom line is also turned into red. Some mistake I am doing out over here. But when I complete that, automatically color changes. So that's the beauty where VIM editor is really helpful to you. So personally, I prefer going with VIM editor. Now guys, before we can go for shell scripting, it is really important that you must be aware of basics of Unix and Linux. This is really important because if your basics are not clear, then there are many things where you are going to stuck upon. And it is not possible for me to repeat all the basic commands once again and to show you all that. You must know how to create a file, how to create a directory, how to list out the contents of the file and directories. All these basic things you must be well aware of. Now I've got a solution for you guys that if you want to brush up your basics, what I do is I have my blog or my website, which is www.musab.in. So you can visit this website, musab.in, and on this website, I have kept Unix basics video tutorials. So you can go to this video tutorial and you can watch the video. Little bit slow internet is there, guys, I'm having, so it's coming a little bit slow, but you may not experience the same thing regularly. So you can watch these videos and you can brush up your basics before we start the shell scripting. But your basics are really important because there are many things which are dependent on basics. I am going to repeat few of the commands, few of the basic things, but not everything. So something we are going to seriously go into deeper of that. So let's see what is the curriculum we are going to follow. So guys, first of all, we'll start as an introduction what we have seen today, like what is kernel, what is shell, types of Linux shell, advantages, disadvantages of shell scripting. Then we'll talk about how files are created, listing, viewing the contents, manipulating directories, and file attributes, owner, groups, permission, all that. These are small things, guys, which we have already seen or we already know in the Linux administration. So we are just going to have a refresher of that. Then we'll talk about processes, how process start, listing, killing the process, and parent and child process. Communication, sending messages to users, sending mails, checking mails, customize mails. This is important because sometimes when you are creating a monitoring script, if anything goes wrong, you want the script to send a mail. So you must know how to send a customized mail by taking certain inputs. Then we've got still some important commands what we are going to talk about. See, we are going to see in a very detail some text filtering commands, head commands, tail commands, grep command, counting words and line, basics of awk, and basics of set command. These two commands are really important that is going to make our shell scripts beautiful. So all these things we are going to cover and then we'll jump into scripting environment where we'll talk about variables, codes, flow controls, loops. In loop we'll see until, while, for, select, flow control, if statement, if else, nested if, case statements. Beautiful options are there. IO redirection, how to redirect the output, exit status, wildcards, and very crucial functions. How to create a function, calling a function, and some advanced concepts also we are going to talk about. And also we are going to see some advanced part where we'll see how to nullify unwanted output using trap command, shift command, debugging a script if you have any issues, any problem, and binarizing a file. See, sometimes what happens, we want our script, I'm sorry, to be in the binary format. We don't want people to see the contents of our script. We want people to use our scripts but not to see the contents. So in that scenario, we will go for binary format. So when you convert the script into binary, then people can use it, but they cannot see what is the content. So we'll see that also, that how to do with this particular concept. And there are a few small but yet powerful commands: xargs, expr, bc, and binary calculator, and sleep command, type command, all that thing we are going to cover up in this particular session. So anyway, this particular thing, what I have shown you, this brochure, this we will be sharing with you after this demo. So you can go through with this thing at what we are going to cover up. So shell script, guys, as I've telling you, is really important concept which can help you to do a huge tedious jobs in a fraction of minutes. And it is all about logics, guys, that how you are going to put logics into your script and it will work as per your requirement. Shell scripting is not like system administration, like you have user add command and you have to use user add in the same way, or user mod go with the same way. Shell script is so interesting that you can do lots of activity with same different things. So doing one activity with different options, that is shell script. Like in mathematics, we have a concept of trigonometry, where what happens is you have a problem and it has different solutions. You'll get a solution, but there are different approaches. So here also, to do a certain task in shell scripting, you can go with different options and you can get your end results. And whatever we are going to see, we will see on some very interesting real scenarios. So every day we will be learning one script based on some scenarios. That makes the total concept even lovable. When you see that how the things will be working out, like we'll create our own customized command as per our requirement. We'll create a script to take the backup of particular thing in the system. We'll create the script to monitor our resources of the system. We will create a script to go and download some data from the other machine. So there are many such things what we are going to do. So every day we are going to see some real scripts, something which is really useful. So we will be seeing how the backups would be taken with the help of script, and how will perform certain tasks like taking backup, putting it onto the other machine, or going to other machine, collecting some information. So every day when we hit to the shell scripting, we will see one real concept, like how this is useful in real scenario. So that makes it more interesting, more enjoyable when we go for every concept and we will relate it to some real time activity. That's what, guys, I'm trying to give you. And this is an advanced level of scripting. This is not the basic part where only I'll be explaining you the concept. With concepts, we are going to see many advanced things into it. And as I've told you, again, I'm repeating it, that every day we will relate our concept with some real thing. So what really happens in real world, we will include into it and we'll make the things work. So that is going to be very beautiful, and I'll be explaining you logic. Now approaches are in your hand. How you can improvise it, how you can change it, and how you can modify it. And believe me, shell scripting is something you're going to enjoy a lot. It is never going to fade out. Every day you can put new thoughts into that scripting, you can modify it, and you can get brilliant output. It's not fixed and mechanical like system admin, like creating user, creating PV, increasing, decreasing. So 2 to 3 days you'll do same task and you'll get bored of. But shell scripting will be an ocean to do many things in different way and to get your work effectively easily. And these shell scriptings are also useful if you are further looking for DevOps and other kind of concepts. See, DevOps is also a bigger type of automation in which also there is a very important role of scripting. It needs you to have knowledge of scripting, any scripting, shell scripting, Perl scripting, Python, Ruby on Rails, or whatever it might be. And if you know shell scripting, then learning other scripting languages will become very simple for you because the concept, the logic remains same. Only working capability and working techniques may be different. So this is what guys we are going to see in our shell scripting curriculum. The overall duration would be around 8 to 10 days, probably 10 days. And in that, we are going to cover a huge amount of stuff with real scenarios. Every day we will see some real concept into it and we'll convert the script for some real usage. So that's it guys for this introductory class. If you have any questions related to our classes and all, you can put forward questions. Okay, since everything is fine, so we will log off for today. Tomorrow we'll again meet at the same time and where we will begin with our shell scripting main concepts. Thank you so very much for attending this session, guys. See you tomorrow.